All right, Mary Louise, as our guest, which topic do you want to start with? What calls to you?
Okay, the origins of the baobab tree, which, aside from being surely the most fun tree to say,
Yep.
this is the iconic picture you see on African savannas, right?
Yeah, they're so beautiful. It's sometimes called the tree of life. They have these thick trunks, a crown of branches, and flowers that only open at twilight. The baobab was the inspiration for Rafiki's tree in The Lion King.
Okay, great.
And there are actually 8 species of baobab adapted for dry climates. They provide food, water, and shelter to entire ecosystems. And the trees can also figure heavily into the diets and folklore of the people around them.
Okay, so the question before us today is the origins of the baobab tree. Why has this been a mystery to scientists?
Yeah, for a tree that's important to so many people around the world, they have no fossil record of this tree. And the family tree, like how they're all related to each other, pointed to 3 possible places of origin: Australia, Africa, and the island of Madagascar. Now, Juan Junan has loved baobabs since reading about them in The Little Prince. Yeah, great book. And he now studies them at the Wuhan Botanical Garden at the Chinese Academy of Sciences.
When I touched the bark of baobabs at that time, I decided to get to know the evolutionary history of these special trees.
And this week, Junan and a global team of researchers published a study in the journal Nature to pinpoint where baobabs likely came from once and for all.
And, drum roll, the answer is?
Madagascar.
Madagascar.
Yes, another animated movie.
Indeed. Why was that so hard to pin down?
Yeah, well, what was missing all these years was a deeper understanding of the baobab's genetics. So sequencing technology has gotten better and cheaper, and this allowed Junan and his team to look at high-quality genomic data from 8 known species.
Although I have seen baobabs, and I have not been to Madagascar, so we know they spread.
Yes.
What happened?
So they think it was by oceanic currents, which may have picked up the baobab fruit and delivered it to Africa and Australia. But now that sea levels are rising due to climate change, the native range of the baobab is shrinking. These trees cannot survive when submerged in seawater.
Yeah, so several baobab species are now endangered, and the habitats of the baobab pollinators, like fruit bats and hawks, they're under threat too. So Junan wants ecologists to take these genetic insights and use them in building conservation plans.
Fascinating. Okay, next story. Gina, I will start with you. Building engineers who are taking tips from lizards.
Yes.
Go.
Yes. So it's a cool innovation to a serious problem, building collapse, like when a building falls down from a natural disaster or just like gives way. And this happens all the time.
Okay, and this has what to do with lizards?
Yeah.
It's a kind of a plot twist. You know how lizards can sacrifice their tail to save the rest of their body?
Mm-hmm.
Okay, take that idea, and this team of researchers in Spain thought, what if buildings could do something similar? Like if only part of the building were to collapse. That would leave a portion for people to shelter in and get rescued from.
Let me give you like another analogy to help you visualize what's happening here. So imagine when a conventional building like falls, the whole thing collapses like a souffle. Mm-hmm. But in this type of construction, only one little slice of the souffle deflates.
Now I'm totally distracted by thoughts of souffles
Yes.
and the fact that I'm hungry. And I'm also trying to picture how that would actually work. If you're not talking about a souffle, you're talking about a building.
Right.
Yeah, so, this could really help keep people safe. So usually in building design, the supports are so interconnected that if a load-bearing column breaks, boom, the whole building comes down. But the team altered those connections and designed the building in such a way that when it started to fall apart, only a part of the building broke.
Which sounds hypothetically very cool. Have they actually tried this in the real world?
Yeah, they built a 2-story building in Spain, and they loaded it up with so much weight that it would collapse when columns were removed. There's a video of this experiment, actually. Yeah, you can hear engineers cheering because most of the building stayed intact. So one of them cheering is Nervin Makund. He's a structural engineer and the lead author on a study about all this out in the journal Nature this week. And he says this idea has been around, especially for like bridge design, but this is the first time it's been tested in the context of a full-scale building.
Well, and I love hearing that cheering and everything, but
Yeah.
what would it actually take, do we know, to get this design into building codes actually being used out in the world?
Yeah, any change to building codes is a potential risk. So innovation in this industry is slow, but assuming you could get through the red tape, Nirvan said it's something that could be built today.
Implementing this in an actual construction doesn't require any special or new techniques.
Another engineer that didn't work on the study, Sarah Orton, she praised the work, and she said that if you can get the engineering just right, it could prevent a smaller collapse from turning into something catastrophic.
Onwards to our third topic. This is the one I'm really excited about. Spending time outside can protect kids' eyesight? How so?
Yeah. Okay. So our colleague Maria Godoy reported earlier this week that spending at least 2 hours outside each day may help prevent nearsightedness in kids. It's a growing problem in the U.S. and many parts of the world. 42% of people in the U.S. are nearsighted, including me.
And me.
Oh gosh, all
Here
of
we
us.
are.
Yeah, and like in the 1970s, it was 25%.
Yeah, research has shown that spending a lot of time looking at things up close, like reading or, like looking at screens, is linked to nearsightedness. And what happens with nearsightedness is that the eyeball stretches out, which changes the way light focuses on the back of the eye, the retina, and the end result is that objects far away look blurry.
Okay, I'm definitely looking up from my screen to ask the next question. just
Protect those eyes.
Yeah, exactly. Flesh out the idea that it's just you go outside, you walk through some grass, touch it, and just
look
so long as
far,
you're
far
outside,
away.
this
Yeah.
is helpful.
Yeah, anything, as long as it's outside.
Why? Why does being outside matter?
So Maria talked to Ian Morgan, an eye researcher at the Australian National University, and he knew from animal studies that sunlight stimulates the eye to release more of the neurotransmitter dopamine, and dopamine can slow the eyeball from stretching.
He wanted to see how this might play out in kids. So in 2008, he and his colleagues designed a study looking at over 4,000 6 and 12-year-olds in Sydney, Australia. The kids who spent more time outside were less likely to be nearsighted, and later on were less likely to develop nearsightedness.
And the study caught the attention of Dr. Pei-Cheng Wu, an eye doctor in Taiwan, where the vast majority of teens are nearsighted by the end of high school. In 2010, he launched a program encouraging all primary schools to send students outside for at least 2 hours a day, and it helped. After steadily climbing for decades, rates of nearsightedness in Taiwan's elementary schools finally started to fall. So it doesn't matter what you're doing, just get outside, enjoy nature, help your eyes.
Sold. 100% sold.
Mary Louise, thank you so much for taking time to talk with us today.
My total pleasure. Thanks for having me.
You can also catch Mary Louise on Consider This, NPR's afternoon news podcast.
Before we head out, a quick shout out to our Shortwave Plus listeners. We appreciate you and we thank you for being a subscriber. Shortwave Plus helps support our show, and if you're a regular listener, we'd love for you to join so you can enjoy the show without sponsor interruptions. Find out more at plus.npr.org/shortwave.
This episode was produced by the best in the biz, Megan Lim and Rachel Carlson. It was edited by Rebecca Ramirez and Christopher Intagliata.
Emily, Rachel, Maria, Rebecca, and I checked the facts. And the audio engineers were Neil Tevault and Patrick Murray. I'm Regina Barber.
And I'm Emily Kwong.
Thank you.